Good morning, lovely children. It is Friday, the 1st of May. Can you believe that we are in the 5th month of 2020? How amazing. I hope you are keeping well. I hope you're keeping safe, but I hope you're enjoying your time and making the most of the 5th month of the year. Okay, so I'm making a quick video this morning because a couple of weeks ago I posted this code breaker multiplication, letters as numbers activity for you, which I believe most of you struggled to access. So I just wanted to bring some things to your memory or to your remembrance, because I know you are more than capable of solving this equation, and it's just about having fun with what we know and working through what we don't know, using what we know to solve things that we initially didn't know. So in this, it's very simple. It is a multiplication table. As you can see, it is the multiplication table of f. Do we know what f is? No, initially, no, we do not. However, our job is to solve that. What else? So here I can see that g times f equals f. At the moment, as we know, they're just letters, but we need to change them into numbers. The numbers are not interchangeable in the sense of the digits remain the same. So f will always represent f. For instance, if f was representing 1, it will always represent 1. However, the place value could change. If it was a 2-digit letter, not a 2-digit letter, you know what I mean, a 2-digit number, then f would be first. And it could still represent a 1, but if something else came after it, it could be a 10 or a 12, depending on what it is. So the place value changes, but it's still the same as what we know in the numbers. I hope I'm explaining this clearly. Okay, so we know that in mathematics we have, in our equation, should I say, when we're dealing with multiplication, it still has the same law of commutativity, just like addition. It can be in any order. However, we have a multiplicand, a multiplier, and when you multiply them two together, initially we could say they are factors, because when we multiply the number together we get a product. Okay, so on this occasion our multiplicand is f, and that's the number being multiplied. As you can see, it's in every single equation. So the multiplier changes, and when we multiply the multiplicand and the multiplier, or the multiplier and the multiplicand, we have a product. Okay, without making this video too long, I'm looking at this and I can see, so we just need to use our reasoning skills. I know you're all more than capable of solving this, and I know that once you watch this video, the comments will come flooding in and you're going to say, oh wow, miss, I can see it, I understand it, it is amazing, can we do another one? And I will find some more for you. Okay, so I'm looking at this and I can see that only one, by the way, they are not in chronological order. A does not represent 1, E does not represent F. They are mixed up. Again, we're using our skills to work out what each letter represents as a number. So again, I'm looking at this and I can see that only one of these equations has a product which is a single digit number. The rest are 2-digit numbers, or 2 letters which represent 2-digit numbers. So could it be the 1 times table? Could it be the 2 times table? Could it be the 3? Could it be the 4? No. Why? Because even if we did 1 times 4, which equals 4, then we do 2 times 4 equals 8. We don't have any more single digit numbers here, so it can't be that. So I know I can move on to 5, to 6, to 7, and I can trial all of that. Also, I can see that g times f equals f. Clearly, only clearly, g must equal 1. G must represent the number 1. The reason being is we know when we're doing a multiplication tables that when we're multiplying a number by 1 or 1 times a number, the answer is always going to be the number which you've multiplied it by, or either your multiplicand or your multiplier. Only when we're multiplying by 1 or 0, because if I did 0 times 5, my answer would be 0. So do you get what I mean? It's the same pattern. However, I know that this is 1 because we don't have a 0 as our multiplier in this. So I'm going to assume that G equals 1. And if I know that G equals 1, then that means 1 times 5 equals, or 1 times 6 equals, or 1 times 7 equals. I'm trying not to give you the answers. I'm really trying because I want you to do it. Similarly, I can see here that GB times F equals FB. Wow, I'm going to use that same principle, and I'm going to say that that G equals 1, but it's not a 1 anymore because it's got a different place value. So is it, it can't be 11 because it would be GG. Could it be 10? Could it be 12? You tell me. There's another pattern I can see. The other pattern I can see is that F times F equals AF. We don't know what A is. However, I know that if that number's 5, 5 times 5 equals, if that A is 2, then it could be 25. Do you get what I mean? Because we have the final digit, or in the ones, the product of F times F ends with that same digit, just it is the same place value, but it's got a different number as its total. Anything else? I'm so sorry, this video is too long. I'm going to stop there. Let me know how you get on. Have an amazing Friday, a fabulous weekend. God bless you, and I will speak to you all on Monday. Bye.